Hello and welcome to this video in which once again we'll be looking at a quant question from CAT 23 slot 2. And this question belongs to the topic of geometry. And this is a very, very easy question. So as usual, as I do in my videos, I will give you a bit of time to read the question, pause the video right here, read the question, try it out yourself. I don't think you will require too much of help to solve a question like this. So try it out yourself and then after that you can have a look at the solution. So this question is talking about a triangle which is perfectly inscribed inside a circle C. Perfectly inscribed means that all three vertices of the triangle are lying on the circumference of the circle. And we have been told that one of the sides of the triangle is a diameter of the circle and the remaining two sides are in the ratio of A is to B. The lengths is in the ratio of A is to B. So let's draw the figure. And if you look at the figure of this question, it will look something like this. And to solve this question, the one and only concept that we need to be absolutely clear about is that angle in a semicircle will be a right angle. So always an angle which is being subtended in a semicircle. Now only diameters can subtend an angle in a semicircle because diameters are the only chord which divide the circle into two semicircles. So anytime a diameter subtends an angle at the circumference of the circle, it will be equal to 90 degrees. So this we have to understand. So what I've done is in the figure, I have named the triangle which the question is describing as PQR, where QR is the diameter and that means that angle P will be a 90-degree angle. So the remaining two sides will be in the ratio of A is to P. So I can say that if PR is A, then PQ is P, or PR is to PQ is equal to A is to B. And we have to find out the area of this triangle PQR. So what I can do is I can begin by assuming the length of PR to be equal to AX and the length of PQ to be equal to BX by taking the proportionality constant X. And of course, QR is the diameter of the circle, which means that length of QR will be 2R, twice the radius. So if this is clear, and if it is also clear that triangle PQR will be a right angle triangle, then of course you have to apply the Pythagoras theorem. So applying the Pythagoras theorem, I'll get QR square is equal to PR square plus PQ square. So I'll substitute QR square as 2R the whole square, which is equal to 4R square, and PR as AX, I get A square plus X, or A square X square, plus PQ square will be B square X square. So simplifying this, I can take X square common, and if I cross multiply A square plus B square to the other side, I get the value of X square as 4R square by A square plus B square. This is all that is required to solve the question from here, because now we have to find the area of the triangle PQR, and PQR is a right angle triangle, which means in this right angle triangle, PQ and PR can be considered as base and height. Right? So I can take PQ as the height and PR as the base. So then area of triangle PQR can be written as half into PQ into PR, half into base into height. So PQ into PR will be AX into BX, which is equal to ABX square by 2. Now all that we have to do is substitute the value of X square in this expression as 4R square by A square plus B square. So when I substitute that, I get the area of triangle PQR as 4ABR square divided by 2 into A square plus B square. Simplifying this, I can cancel out 2 from the numerator and denominator. Answer will be 2ABR square by A square plus B square, which is given to us in option B. So answer to this question will be option B. Right? Very simple question. Hope the solution is absolutely clear. Thank you.